section 7.5. Rationalize the denominator. What does rationalizing mean when we ask you to rationalize the denominator? So let's say you have a fraction which is 1 over radical 3. And we want to rationalize the denominator. Rationalizing means you don't want to have any radical at the denominator, okay? So here I have radical 3, and you understand the root is 2. So if I take this and multiply by radical 3 over radical 3, you understand, if you multiply by something like this, means like you multiply by 1. Nothing changed. Like if I have 1 over 5, right, and multiply that by 2 over 2, does anything change? No, because it's like you multiply by 1. You know, it doesn't look like 1 over 5 is 2 over 10, but still the value is 0.2. So if I take 1 over 5 and multiply by, you know, like 7 over 7, does anything change? No. It sounds like you're multiplying by 1. So here, to rationalize or to remove radical from the denominator, you multiply by radical 3 over radical 3. So what you have at the top is radical 3. At the bottom, you have radical 3 times radical 3. What is radical 3 times radical 3? When you multiply two radical and you combine, it would be like that, or just equal to 3. So anytime you're taking a radical and multiply by itself, what happens is you don't have radical anymore. So radical 5 times radical 5 is just 5. Why? Because when you multiply, again, when you combine these two, you have radical 25, right? Or radical 5 over 2, which is 5. So what is radical, let's say x2? I'm sorry, what is radical x times radical x? X. What is radical a minus b times radical a minus b? Just a minus b. What is square root of 17a times 17a? Again, 17a. So anytime you're taking the radical and multiply by itself, in case of root of 2, you remove the radical. So we are using that property here. We multiply this fraction by 1, which is radical 3 over radical 3. So what happened is at the top is radical 3, at the bottom is radical 3 times 3 is 3. So what I did, I rationalized the denominator, means I remove radical from the denominator. Now I have a radical at numerator, it's okay. We just don't want to have any radical at the denominator. So when you say rationalizing the denominator, means work on these fractions and remove the radical by doing this. All right, so how do I rationalize the denominator? Just multiply by radical 3 over radical 3, which is 3 here, and radical 6. See? Rationalizing denominator. Denominator change from radical 3 to just 3. This is rationalizing. Rationalizing the denominator. In a case like this, we understand that if you have radical a over b, you know, we had it in previous sections, you could break it into radical a over radical b. You could break it into two radicals if you have fractions on. So here we just write it as radical 16 over radical x. We understand radical 16 is 4. If you use your calculator, radical 16 is 4 over radical x. So this is what I have so far. Now, they want us to rationalize the denominator. They want us to move radical from the denominator. So we'll multiply this by radical x over radical x. Then what I have is x here, and for radical x, I don't have radical at the denominator anymore. I rationalize the denominator. So to rationalize the denominator, you see what denominator you have? You multiply, like here I have radical 2x, right? So you multiply by radical 2x over radical 2x. So now I have just 2x here, and here I have 9 radical 2x. See what I did? I rationalized the denominator. I want to rationalize denominator is radical 3, right? So multiply by radical 3 and radical 3. So here is just 3. And 7 radical 6, because radical 2 times radical 3 is 6. Now, let's say I want to do this one. 2 over cubic root of like 7, okay? I want to rationalize the denominator. Shall I go ahead and multiply this by cubic root of 7 over cubic root of 7? See what happens if I do that. Then I have here cubic root of 7 times 7, and here 2 cubic root of 7. And then at the denominator, I have cubic root of 7 to power of 2. Can I remove 7? No. The power must be 3. See, this is different. Like if I give you a problem like this, look. And I do the rationalize, you just say, okay, you see the root is 2 if you don't see any number. When you multiply this by radical 7 over radical 7, then here you have 7 to power of 2 or 7, because the power is 2 and the root is 2. But that's not the case here. So if the root is 3, do not multiply just by 7. Multiply by cubic root of 7 to power of 2, or multiply by 49. Because in that case, then you have under the radical, you have cubic root of 7 cubed. At the top, you have 2 cubic root of 49. These two cancel. Then you have 7 here and 2 cubic root of 49. You see that? So it's not just when you see a radical, you should just go ahead and multiply. What you need to watch is what is root of that radical. Okay, so now let's go work on this problem here. I have, first I write it as cubic root of 7 over cubic root of 3. Then I multiply this by cubic root of 9 or 3 to power of 2, okay? So then in this case, you have cubic root of 3 to power of 3, which is 3 here. And then what do you have at the top? Cubic root of 7, cubic root of 9, or cubic root of 63. Let me show you another example. What if I have 1 over, this is example, 1 over 4th root of, like, I don't know, like 5. Then you multiply this by what? 4th root of 5 to power of 3, okay? See, because in that case, at the numerator, you have 5, 4, and here you have 4. So it's 4th root of 5 to power of 3, which is 125. Now look here, because 5 times 5 to power of 3 means 5 to power of 4, and 4 cancel. See, what you have at the denominator is just 5, and at numerator you have 4 root of 125. So it depends what the root is. If under the root you have 5, 1, means you need another 5 times 5 times 5. All right. Some of the problem like this one, rationalize the denominator. Okay, for that one, I attach a copy of the solution for this one, which is this one. So what you do is first go ahead and divide 256 by 8, which is 32. And when we break 32, 32 is 2 to power of 5th, which is 2 to power of 4 times 2. So this 2 to power of 4 comes out, and 1 to remain. This one is a very, you know, the next one, let me see, number 7. And number 7 here, this is a long problem. Look, you have a 5th root here. So you cannot just multiply by the same radical, okay? So for that, I have the solution for you here. What I did first, I tried to remove some of the factors. You know how you have a to power of 5th? Where I got that is you had this equation was like this. It was okay, let me do something here so you understand it. Right. You see how I have a to power of 7 here? A to power of 7, I write it as a to power of 5th times a to power of 2. B to power of 13, I write it as b to power of 10 times b to power of 3. Why? Because I want to write it with the number that is multiple of 5, like 7. If I change a to power of 7 to a to power of 5 times a to power of 2, this 5 is multiple of 5. Or if I change 13 to 10 and 3, 10 is a multiple of 5. So now one by one, this a, 5 and 5 cancel, a comes out. Okay. B10, 10 divided by 5 is 2, so B2 is coming out of the radical. What is left is this, and A cancel, so this is what I remain. This is what we have so far, this one. Now, to remove the radical, I should write the same radical here. If this is fifth and this is 4 to power of 1, I need 4 to power of 4 here. If this is A2, then I need to put A3 here. So when you multiply these two is A5. I have B3, so I need to put B2, so 2 and 3 is 5. And you put the same thing at the top. Now, by doing that, see, now I combine the radicals so you could actually see it. I combine these two, so 4 to power of 1 times 4 to power of 4 is 4 to power of 5. A2 and A3 is A5, see I showed it here. B2 and B3 is B5, okay? These are all denominators. Every single number and variable are coming out of the radical. So see, you don't have radical at the denominator anymore. But then I simplify, 256 is also 2 to power of 8, which you write it as 2 to power of 5 times 2 to power of 3. 2 comes out of the radical. 2 to power of 3 is 8. And then simplify. And this is a long problem, but it has a lot of calculation in it. So you have to also break 2 to power of 8, which is, you know, here, this 256, you could break it like that, yeah. See how many 2's are there? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 2 to power of 8 is 256. That's where we put it here. But because this is 5 and this is 8, you write this as 2 to power of 5 times 2 to power of 3. So you could take one of the 2 out. And 2 to power of 3, which is 8, stay under the radical. So that was number 7. You know, there are 2 types of rationalizing for the denominator. One, we discussed if you are dealing with just one radical. Let's say you just have one radical. In that case, we say, well, just multiply this by radical x over radical x, right? So that would take care of the denominator. What if you have something like this? You don't have just one radical, okay? You are not multiplying by the same thing here. Because if you do, that doesn't let you remove the radical. Look, this is not the right way, but I want to just show. If you take this and multiply by itself, see what happens. Is x minus radical xy minus radical xy plus y. These two do not cancel, so you have x minus 2 radical xy plus y. You still have the radical at the denominator. We don't want that. What you need to do when you see a difference or sum of 2 radical like this, you had a formula that if you have a minus b conjugate times a plus b is a2 minus b2. We use that here. So what you do is when you have 1 over radical x minus radical y, you take that and you multiply that by conjugate. Look, the same radical with the opposite sign. You do it this way. See? Because in that case, the top is this, and when you multiply the bottom one, you get x plus radical xy. You bring this one minus radical xy minus y. See, these two cancel. What is left is x minus y. It means now you don't have any radical at the denominator. So in the case that you have the difference or sum of 2 radical, do not multiply by itself anymore. Always multiply by radical that the sign, the middle sign, is opposite of that. Okay? So now we see how we use that for this problem here. 3 minus radical 11. So multiply this by 3 plus radical 11 over 3 plus radical 11. See, multiply by the same parentheses, but with the opposite sign. So in that case, when I distribute, 3 times 3 is 9, plus 3 times 11, then you bring minus 11 and multiply, minus 3 11, minus 11, and then at the top you have 8 times 3 plus radical 11. Now these two are equal and opposite, cancel. So what you have is negative 2, and here is 8, 3 plus radical 11, right? So 2 goes to 8 is minus 4 times 3 plus radical 11. And if you want, you could bring the minus 4 and multiply. So it's negative 12 minus 4 radical 11. There is no denominator. See, it's 1. We rationalize the denominator. So you always multiply by the same parentheses with the opposite sign, like this one. They are asking us to rationalize the denominator. So never mind what you have in the denominator. Denominator needs to be rationalized. So in that case, we multiply this by, what is this? Radical 5 plus 6. We multiply by radical 5 minus radical 6, which you already have it here. Then, when you multiply this, is 5 minus 6. And at the top, you have see, denominator is already rationalized, it's negative 1. But then you could just go ahead and multiply these, which is 5 minus radical 30 minus radical 30 plus 6. So it would be 11 minus 2 radical 30, and then you have a negative 1 comes to the top. Make it something like this. As long as you understand that there is no number at the denominator. Okay. Same thing here. Look, 10 is 1 plus radical 3, right? So multiply this by 1 minus radical 3. Then what you have at the denominator is what? 1 minus 3. At the top is 9, and then you distribute 9 into that. 9 minus 9 radical 3 over minus 2. And you could also write it like this. You don't have to, but sometimes that's the way they want it in the book. Number 11. So what do? You just multiply by the same thing with the opposite sign, right? Let me see if I think I have the solution for you for that one. So you multiply by the same one with the opposite sign. It's negative, you multiply by positive. So what I did here, when you multiply these two, I show it here. When you multiply the top one, you have, see, bottom one, you don't have radical anymore, 122. But the top is okay because we try to rationalize the denominator. We don't care about the numerator at these problems. Rationalize denominator means try not to have any radical at denominator, which we don't. Okay? So I have the solution because it was a long problem, so I put the solution for you here. Number 12, let's just write it as radical 18 over radical 5. But remember, here they ask us to rationalize the numerator, not the denominator anymore. Okay, I have it here, the solution for it. When we ask you to rationalize the numerator, means multiply both sides by radical 18, whatever it is. Here I have radical 18, just put the radical 18 here. So what is radical 18 times radical 18? 18. See, you don't have radical at the numerator, means we actually rationalize the numerator. And the denominator, we just do some simplifications here. Here, 13 is the cubic root. Remember, if it's a cubic root, when you want to do the multiplications, you know, don't multiply by just cubic root of 11x. Multiply by cubic root of, oh, I'm sorry, we want to rationalize the numerator, right? If you have 13, put 13 over 2 here. If you have y2, put y. So when you multiply the top one, then you have 13 times 13 to power of 2, it gives you 13 to power of 3. Y to power of 2 times y, it gives you y to power of 3. We don't care about the rationalizing the denominator. We want to rationalize the numerator. We want to move radical from the numerator. So here, this cancel. 13 by c. There is no radical at numerator. We rationalize the numerator. And you have a very large number at the bottom. So rationalize the numerator means try to remove that from, try to remove radical from the numerator. Rationalize the numerator. Numerator is radical 2x, right? So you multiply by radical 2x, radical 2x. So you have 2x here, and here you have 13 radical 2x. Rationalizing the numerator, you multiply both sides by 2 plus radical 3 and 2 plus radical 3, because you want to rationalize the numerator. So that would be 4 minus 3 over 2 times 2 plus radical 3. So it's 1 over, and if you distribute 4 plus 2 radical 3. See, I don't have any radical at the numerator. It just depends. If we ask you to rationalize the numerator, means remove radical from the numerator. If we ask you to remove the denominator, means remove radical from the denominator. So that would be end of section 7.5.